So here you calculate the difference between the upper limit of one class interval and the lower limit of the next class interval. Okay, so that is, here the difference is 10 minus 9, that is 1, then half the difference. Now this half of the difference will be deducted from the lower limit and it will be added with the upper limit. Okay, so first of all you find the difference between upper limit of one class interval and lower limit of the next class interval, then half the difference, then that half the difference will be deducted from the lower limit and it will be added with the upper limit. Then here the difference is 1, 1 divided by 2, that is 0.5. So 0.5 will be deducted from lower limit added with upper limit. Again 0.5 will be deducted from lower limit and added with upper limit. Then you will get the class interval as 4.5 to 9.5, 9.5 to 14.5 till 24.5 to 29.5. Okay. So in your text there is a mistake. It is taken as 5.5. It is not 5.5. It is 4.5. Okay. Then class interval, frequency. Then now you have to calculate the mean and standard deviation, which are the parameters. Now how to calculate the mean and standard deviation? You know there are three equations. In the first question we used direct method. In the text you are given step deviation method. So we can use the second method, that is shortcut method. In shortcut method, the formula to calculate mean is a plus sigma fd divided by n, and standard deviation is square root of sigma fd square divided by n minus sigma fd divided by n the whole square. Okay, so calculate the mid value, that is x7, that is 4.5 plus 9.5 divided by 2, then 9.5 plus 14.5 divided by 2, you know. So that is 7, 12, 17, 22 and 27. Then calculate d. D is equal to x minus a. A is the assumed value or assumed mean. So here assumed mean is taken as 17. That is the mid value. So the middlemost value 17. So 7 minus 17, that is minus 10. 12 minus 17, that is minus 5. 17 minus 17, 0. 22 minus 17, 5. And 27 minus 17, that is 10. Then FD, that is frequency into D. 10 into minus 10, 22 into minus 5, 40 into 0, 21 into 5, 7 into 10. Then comes D square for calculating standard deviation only. So D square is minus 10 square, minus 5 square, 5 square and 10 square. That comes 100, 25, 0, 25 and 100. The next column for FD square, that is F into D square. 10 into 100, 22 into 25, 40 into 0, 21 into 25, then 7 into 100. So total frequency comes to 100. Total of FD column, that is minus 35, and total of FD square column, that is 2775. Okay. Now calculate mean and standard deviation, that is A is 17, that is the assumed value 17. So it is 17. So 17 plus sigma FD, it is 35. So 35 divided by 100 is equal to 17 plus minus 0.35, that is 17 plus minus 35 divided by 100, that is equal to 17 plus minus 0.35, that comes 16.65. So mu is equal to 16.65. Then comes standard deviation, that is square root of sigma fd square divided by n minus sigma fd divided by n the whole square. So that is 2775 divided by 100 minus 35 divided by 100 the whole square. So that is 27.75 minus 0.35 the whole square. So it will be square root of 27.6275, that is 5.25. So you got mu is equal to 16.65 and standard deviation is equal to 5.25. Now you can calculate the Z value, then the area from the table and all. That is the 5 column table. 5 column table, the first column is for class interval X, then the second column for Z, third area from the table, fourth area for the class, that is P of X, and finally the theoretical frequency. Okay, so the class limits are 4.5, 9.5, that is the class limits are 4.5 to 9.5. So the first extreme value is 4.5 and the last extreme value will be 29.5. So 4.5, 9.5, 14.5, 19.5, 24.5 and 29.5. Then z, that is x minus mu divided by standard deviation, that also you know, that is 9.5 minus 16.65 divided by 5.25. Here the value is already known, that is area from the table is assumed to be 0.5000. So this value and the value for 29.5, that is both extreme values. It is assumed to be 0.5000. Here also 0.5000. So you need to calculate only this much. So 9.5 minus 16.65 divided by 5.25. Then last is 24.5 minus 16.65 divided by 5.25. So the value, that is z values, are minus 1.36, minus 0.41, 0.54, 1.50. Here also there is a mistake in the textbook. It is taken as 15.5 but it is 14.5. Okay. So you know how to calculate or how to find the table value from the standard normal distribution table. So it is the table value for minus 1.36 is 0.4131, then it is 0.1591, 0.2054, 0.4332. So these are the table values. Here also I think there is a mistake. It is taken as 0.4322. It is 4332. Then area from the class, that is P of x, it is calculated as 0.5000 minus 0.4131, that is 0.0861. Then 0.4131 minus 0.1591, that is 0.2540. Then one negative and one positive. So you will be adding these two values. So 0.1591 plus 0.2054, that is 0.3645. Then again positive values. So 0.4332 minus 0.2054, that is 0.2278. Then 0.5000 minus 0.4332 is 0.0668. So this is the P of x values. Then calculate theoretical frequency, that is their theoretical frequency is P of x into total frequency. You know the total frequency is 100. So it is 0.0861 into 100, 0.2540 into 100, 0.3645 into 100, 0.2278 into 100 and 0.0668 into 100. It comes 9, 25, 36, 23 and 7, that is the total frequency is 100. Okay, hope it is clear. ഒന്നുകൂടെ പറയാം.